Okay, so today we are going to continue to talk about the second type of the statistics. So yesterday we talked about one kind of the statistics, and later I thought through. Then probably I'm thinking we can call it like a statistic by loads. Okay, yeah, because we need actually we need the information of the individual loads in order to like get some aggregated information. I'm not quite sure whether you have a better idea for this one. I mean, please actually give this as one of the questions you may think about. Do you have any better idea for this? Or maybe I just refer as a statistic by loads next time. So if you heard about this, you know what does this mean. Okay, then the other type, maybe you can call the statistic on time. Okay, yeah, it's actually a statistic on the time and horizon. So I think I will use this one. This is a graph to show you. So what does it really mean? I think you have saw this many times. So basically, if we want to look at the statistics related to this kind of the curve, okay, then it means that it's actually a statistic on the time because this is actually the time horizon. Okay, then in C sharp, no, in the O2DES.net, So actually, we are looking at the statistic in the dimension of the time horizon. We represent it in the unit of hours, and this one will unit of the count. Okay, actually a number. Okay, so this will be the count on the y-axis. So that's why we call this one. Okay, we call this things in our O2DES framework as hour counter. Okay, basically just say it's actually accumulated information of the counts on the time dimension. So our counter it actually has this meaning. So what kind of a statistic we are looking at? So we can refer to this a conceptual diagram of the queuing system. So now if you're interested in this queue, we want to answer the question is what is actually the average length of the queue. So in that sense, it's actually a statistic on time, meaning that so this queue here actually has called a buffer. So if you look at the buffer, when the time goes on, then we can see that the number can be from 0 to 1 because as a 1 loads arrived. Then immediately goes to a server, so it drops to 0 again. Then after some time, there's another arrive, but this one is because server is busy, then it keep as 1 for some time. Okay. Then after the load leaves, then this one entered, it's become the 0 again for the queue. Then after some time, another one comes and join the server. Okay, drop to 0 again. Then another one comes, and waiting the queue. One more comes waiting the queue, become 2, etc. So you can see that this is what is really happening in the systems. But the answer we're asking is what is the average numbers in a queue? What is the average queue length? So what does this mean? Meaning that when they change from 0 to 1 to 2 to 1 again, so what is the average number? So how do we answer this question is that we need to take the, I should say the integral, okay? We should need to take the integral of the count on the time. But because this is actually a discrete event system, so the integral will be very easy to calculate. So basically it's actually the average. Actually it's the area. The integral is actually the area under this curve. Okay. Then we need to use this integral divided by the total time. Okay. And we see that this area under the curve is simply rectangle. Okay. And this one only true in the sense of the discrete event simulation. I think this one we need to bear in mind. This is only true in the discrete event simulation because the change only happens at a discrete time point. Okay, so that's why the integral is actually the area of all those different rectangles. Okay, so this actually makes the calculation quite easier, and this actually the mechanism how we implement this hour counter in the O2DES.net framework. Okay, so we want to answer these questions, so we don't need to like write the calculation of the rectangle explicitly in your program, but you just need to use the hour counter. Okay, so how do we use that? Okay, let me demonstrate to you. So the first one is we need to create a statistics. Okay, so that's why we need to create an hour counter here. So an hour counter, because it's actually a statistic collecting the dynamic information. So itself is actually a dynamic information, dynamic properties. So that's why we need to put an hour counter here. Okay, to see that this is actually an hour counter for, yeah, maybe later we can do a several hour counter, but here we just do it for queue. Okay, so we do the hour counter for the pending loads. Okay, we do this one as a hour counter for the pending loads. Okay, so basically it's actually for the queue lah. We actually do a statistic on the queues. Okay, then after this, okay, we need to initialize. So remember these things. Whenever we define a dynamic properties like this or like this, we need to initialize it, okay, to set initial value, either here or in the constructor, okay? Except that, okay, those information are purely getter, meaning that the information of these things is read-only, and the value actually depends on the other dynamic properties. So in that case, you don't need to set the initial value because it's just a getter, okay? It's just a no setter, okay? It's read-only, okay? So in that case, we don't need to initialize. But this one, okay, because the dynamic properties, so we need to initialize. Then here, bear in mind that our counter have a special way of the initialization because our counter later need to be synchronized together with the simulator, with the sandbox. So it's not kind of an independent or standard data structure under C#, but actually it's a class defined under the O2DES framework, which will synchronize closely with a sandbox, okay, some of the properties in the sandbox. So that's why we cannot simply say here we create a new hour counter. We cannot do so. We cannot do so. Here, if you mouse over, you'll see that does not have a constructor that takes a 0 argument. So let's see whether they get other constructor. Actually, it's not. So our counter actually does not have a public constructors, okay, defined. Okay, so how can we initialize our counter? You need to do this. Remember, this is something you need to do. It's in the hour counter pending loads. You need to use this method called the AddHourCounter bracket. You need to use a method defined under the sandbox to create the hour counter and add it to the sandbox. Or make it short is that our counter is actually attached strongly with the sandbox. It's actually a properties to be affiliated to the sandbox. So that's why we can only do in this way. Okay, we cannot create a separate independent hour counter. So this is one thing's very, very important. Why this is important? Later you will see that. Yeah, because of this, we actually make the usage of hour counter very, very convenient. Okay, so this is what we can do, okay, to initialize the hour counter. Okay, so when this is initialized, then what we are going to do is every time we observe, okay, a change of the value. So what we do is that we simply need to tell the hour counter, now we observe a change, which increased by 1, decreased by 1, increased by 2, etc. Or maybe tell the hour counters what are the absolute value you observed, whether the current is 1 or current value is 2. So I show you that how can we do these things. For example, when the arrive event happens, when we observe this number in Q++, okay, increased by 1. So in this case, when the arrive events happen, so what will be the value change we are observing here? Anyone can tell me? Yeah, anyone can tell me? I'll give you a certain.
It will be 1.
Yeah.
Yeah.
It
Sir,
will be
it
what?
will be 1.
It will be 1 or it will be increasing by 1?
Increasing by 1.
Yes, yes, yes. It will be increasing by 1. So in that case, what we can do is we call this hour counter pending loads. Then to see that now we observe a change, which the change is a positive 1. So this is what we can do. Okay. Then similarly, okay, when we goes to start, we see this is a number in Q minus 1. Okay. So what we are going to do is here is what are the change. What are the change to this observation?
Sir, decrease by 1.
It decreased by 1, right? So in that case, what we need to do is we call hour counter pending loads and observe change by minus 1. Okay. So this is what we're going to do. Yeah, so basically this is all the things we need to do by telling the hour counter some information. Yeah, because the change of value only happens at these two events, right? And here when we see it increase by 1, decrease by 1, we do not really care which is the load because it doesn't matter, right? Because we're actually counting the number. So that's why which is the load is not important. We just need to tell the number. So this is not the statistic by loads, but actually we need to observe the changing of these values along the time. So that's why this is a statistic on time. Okay, so this is how we call it. Okay, and also one thing I want to tell you is that here we can do two ways. One way is to say observe change by the relative change, or alternatively or equivalently, for in this case, what we can do is we observe by absolute value. Okay, so we can see observe count instead of change. So what would be the count, the absolute count here? Instead of 1, so what is the observe absolute count value for the number we are going to have the statistics?
In Q.
Number in Q, right? It's actually this number. Okay. So this will be equivalent as shown here in this case. I said in this case, okay. If it's not if it's a different, then meaning that it might be some bug in this program. So similarly here, we can also do these things. If you observe the absolute value, we can do in this way. Okay. So now let's just, I think usually I like to do in this way lah. Yeah, but two-way actually is equivalent. Okay. So now I will show you that how effective or how like easy we can query for those information is we can actually get like create another value we call maybe not here lah. Okay, not here. Let's do in the program. Okay, so let's just like output one more information, which is average queue length. Okay, in this case, what we are going to do is we can remove these things, and also the minutes we can remove. So what we're going to do is we're looking into this hour counter pending loads. Then we just put dot, then query for the average count. Okay, we put average count. Then we run the program. We can see that by simply adding this, maybe just a 1, 2, 3, 4 lines of the code, 5 lines of code. Okay, so we can actually get the average queue length at 1.92. Okay, so this is actually the average number. Okay, so similarly, we can also do for other statistics, like for this one, beside the interest in the average queue length, and other things we want to interest in actually the utilization of the server. Okay, so in that case, we will see that when the start event will actually increase by 1, and the end event will actually decrease by 1. So let's go back to the model. We're just adding this part. Similarly, we'll do create hour counter here. So here is a pending loads. We'll put another one is in server. Probably I think I'll get a better name which is corresponding to this guy lah. Okay, so we can see that we change the name to, yeah, remember the shortcut key is put the mouse down, click this one, and Control R 2 times. Okay, then we change this one as in queue. Okay, I can make it a consistent hour counter for in queue, hour counter for in server. Okay. Then similarly, we do exactly the same thing here. Hour counter in server, add hour counter here. Okay. I will put a hour counter in server. Oh, sorry, no. Just now we said that what is the time we should increase the value is at the time of the start, right? So actually it's here. And you can also observe this thing when the number in server increase by 1. So here we need to see that our counter in server is actually observed change by 1. Okay. Then similarly, we need to do another things at the end event, but the number in server -1. You don't have these things. Okay. Our counter in server observe change -1. Okay. So here we'll see that average utilization. Or maybe here we got another. Yeah, because utilization is usually divided by the capacity. Maybe here we just maybe call utility first. Or what is a better word? Yeah. Okay, yes. So here we use our counter in server, then similar things dot average count. Then remove the part, the other part. Okay. Okay, then here we can see that, yeah, because now the capacity is 1, so this actually equals to the utilization. So it become 72%, okay, for the utilization. Okay, then with this one, yeah, maybe you add another one. Is actually in system. Okay, so you can see that when the things come, either it will be in the buffer or in the machine. So maybe at the time it arrives, we add 1, then only after it's a finished process, we -1. So maybe we have our counter for the whole system, then to see that what is average number. So by right, this number should be the sum of the one in the buffer and the average number in the machine. Okay. So in that case, let's go to the model. Here, our counter in system. Okay. Then here at the time it's arrived, we let in system to be observed by change +1. Then only at the time it's left and then we observe the change by -1. So we back to the program. We back to this program. Then we write these things, average in system. Okay. Then basically we just need to change this part, system. Okay. Average count. Let me see what is happening. Okay, sorry, I forgot to do one thing is to initialize it. Okay. Our counters system. Okay. So here you can see that this 2.65 is exactly the 1.92 plus 0.72. Okay, so this is average number in system. Okay, so by now, any questions? Okay.
No, sir. Yeah, okay.
If no, then we will continue. I will talk about some of the more advanced functions of the AddHourCounter. Okay. So one of the functions of the AddHourCounter is actually the capability to do the warm up. Okay, to do the warm up. So warm up, what does this mean? If you look into this one, so you can see that this system actually starts from empty. Okay, it's not a stationary state. Okay, so if you run for some times, because it's all start from a 0, 0, 0, nothing arrived, nothing in the buffer, nothing in the machine, right? But it will run the system for a while until like somewhere you see that it's reached a steady state. In the steady state, meaning that actually the jump the state from the 1 to 0, 0 to 1, 1 to 2, actually, change within this range. So you can see that if you take the average of the left part and take the average of the right part, then you can see that actually a significant difference, okay, between these two portions. So that's why if you use the left-hand side, okay, use the status of this part to represent the whole system at a stationary status, it will be biased. okay? Because it's just because you are starting the system from code, from nothing. So that's why the value, the queue length is small. It's not because your service is efficient, for example, okay? So in that case, the result will be questionable. So that's why when we run the simulation study, especially when we start from the code system, I mean, everything is empty. So what we usually do is we let the system run for some while, then we cut, okay? We do a warm up until, I mean, a certain time point, we cut, and all the things on the left will be removed. So when we look at average, we only look at average on the right portion. Okay, so this is what we are going to do, but how can we execute these things in the simulation model built by O2DES? I mean, if there's nothing implemented in the AddHourCounter, this will be quite tedious for doing this, but with AddHourCounter, this is actually quite easy, okay? We don't need to do anything in the model, okay? The model is actually, as I mentioned last time, is how we create this toy. Okay, so warm up is actually something how you control, how you play with this toy. So it has nothing to do with the model here, but rather it actually goes to a program. It's actually at a program. How do we play with this model? So here you can see that after the model is initialized, so we run for 24 hours, right? So now what we are going to do is I want to warm up this system for maybe 2 hours, then I will run it for another 24 hours. So if in that case, how should we do it? We simply add model.run, warm up, okay, for like a time span from 2 hours, from hours. Okay. Then we run the simulation for 20 hours. Then we see what the results. So if you do it in this way, you can see that, I'm not quite sure whether, what is the value just now? Let me just take some comparison. Yeah, maybe you run for a shorter time. I think the effect will be quite the effect will be quite obvious. So we just run for 1 hour. Let's see what are the results. Okay, so you see that average queue length is 0.49. Okay, without warm up. Then if with the warm up, we will expect to see the queue length will be longer. Oh, sorry. I think because of the, we're lucky. Yeah. Because it's random, so we cannot control this number. But anyway, okay. Anyway, I think you should understand the principle of the warm up. And this is not a very good use case. Yeah, probably I should further short it down. But it's okay. So I just use this one to show you that whenever we have this command, so what we are going to do at the end is that we actually run the simulation for 1 hour. Then we will remove all the accumulated information from all the statistics, okay, on time. Okay, so now the static on time is actually the AddHourCounter, right? So if you do a warm up, and this warm up is automatically applied to all the AddHourCounter added under the sandbox. Okay. Then when you run the simulation again for another hour, so all the statistic collected here is just for the second hour. Okay. So this will be the principle. This will be the functions. The first one is the supporting of the warm up. But you may also ask another question is, what happened is that yesterday you talked about statistic by loads. What if we also want to have a warm up of those loads, meaning that I just want to remove all the completed loads, okay, at the end of the first hour, or is at the time when you do the warm up, okay? So how do we do so? So in that case, we can go to the model. Then we specifically tell the simulation model what are the other warm-up options you want to do. For example, now when doing the warm-up, I want to reset this process list. Okay, I want to reset this process list. Okay, so in that case, what do we do is we need to overwrite the warm-up functions handler. Okay, So we need to overwrite this warm up handler. Okay, so instead of to execute the base one, which actually going through all our counter and warm them up, okay, then we just adding another thing is we need to process list. I want to reset it. Okay, new customer. Or maybe let me see whether I can use remove all. Yeah, I think it's better to use this one. Okay, I will remove all. I think this will be the customer. This is basically meaning that for all the customer in the list, I want to remove them. So this is actually a condition. So whenever there's a customer, I will return true, meaning that I decide to remove. Okay, so this is how we can warm up to remove all the processed loads. Okay, so in that case, when you executing these things, so after 1 hour, okay, this list will become empty. Okay, so yeah, if you don't believe, I just want to do one experiment for you. Okay, model.wrong and time span from 1 hour. Okay, so I just pause it here. I'll show you that if I run for 1 hour, at the end, you will see some things. Model, you will see the processed list. Okay, you see that it's the 17 element here, right? But if we just warm up for another hour, okay, you will see that this process list is empty. Yeah, because it's run for another hour, then they empty the list. And also at the same time, if you want to look at those hour counter, okay, you can see that some of the value is all resetted. Okay, it's all resetted to 0. Okay, so this is actually about the warm up. Any question now?
Yes, sir. Yes, sir.
Yep.
Sir, two, three questions. First,
Yes.
like when we do the warm up, automatically
Yes.
after 1 hour it will remove and then start to record the results after 1 hour, like this.
Yes. Yes.
Okay. Okay. Second
Yes. Yes.
question, sir.
But maybe I just want to add one more is the hour counter or those statistics actually have a two kind of information is recording. One information is the cumulative information. The other one is the snapshot information. Let me take this one as an example. Okay, let me take this
Okay.
one example. If the warm up is happens at this time where the pointer is point 2 lah, okay. So you see that the cumulative information is actually the gray area on the left, right? It's actually this whole area plus a little bit area here. So this will be the cumulative information. So when we do the warm up, okay, now it's actually meaning that this area will be reset to 0. I mean, all the gray area will be removed so that the cumulative value will become 0. But the snapshot information telling that now there actually there's a one customer in the queue, right? So this one is a 1. So if you see this red line is a 1. So this value will not be reset. Okay, this value will not be reset in a sense that this one will still keep there. Okay, so I think this is actually a concept you need to bear in mind. Cumulative information will be removed, but snapshot information will be maintained. Otherwise, we lost the purpose of the warm up. Meaning that if this one reset to 0, then why did you like just start there from the beginning? Okay, so yeah.
Yeah.
Okay, yeah.
Okay.
Maybe you
Okay.
continue to the second questions.
Yeah. So, sir, the second one is like many times we say that we don't, when we take the average, we don't take if there are plenty number of zeros. So if we get more number of zero in the buffer, then the program is calculating the median or it is calculating the mean. So that is why we have introduced the concept of warm up, so so that we are
Are you
taking
talking about
different.
the statistic on time?
Yes, yes.
Yeah. So if it's static on time, so I'm not quite sure is what do you mean by number of the zeros? So
Like yeah, we can see here buffer, it's zero, zero, then one, then zero, zero, then one, two, like this.
yes,
So
yes.
so if we encounter similarly, moving forward, if we get zeros in the buffer, so we will take them into the consideration while taking average, or we will not take them into
Okay,
consideration.
as I mentioned, is that it actually doesn't really matter that
Okay.
how many times you observe zero. Okay,
Okay. Yeah.
it doesn't
Yeah.
matter how many times you observe zero or how many events that you actually observe the zero. Okay, when those events happen,
Mhm.
what is really matter is when you observe a zero, how long it lasts. Okay, until the
Okay.
next time you observe a different value. Okay,
Okay.
you see that
Okay.
from here to here. Okay, also you observe zero one time, two times, yeah, two times, okay, until this time you observe one, okay.
Yeah.
But actually, this two time does not matter. Even if it's only observe one time until here, the result will still be the same. Okay, or even you observe a lot of events in the between, but all zero, it doesn't matter.
Okay.
What matter
Okay.
is after the first observe the zero until this value change to one, how long is past the total? Okay, because
Okay.
this one will contribute to the area under this curve. It will be zero times the time length. It will be the cumulative value. Then when you shift to one, the important thing is how long this one will last. Okay, so we
Okay.
use a one times the time length, we get the area under the curve for this grid rectangle. So this will be important. So when we say the average value, so it's actually this average value does not related to how many times you observe, but whether the time the length will be important.
Okay.
Then,
Yes.
then the other thing is actually just now you mentioned about the medium.
Mm-hmm.
Okay, so if you think in this way, this kind of average, I'm not quite sure how the medium will be defined, because medium is actually to see that if you have a lot of the discrete like observation, I mean discrete observation. So here you can see that our counter is actually observing using a discrete way to observe a continuous performance. You see that this performance is actually continuous. The time is continuous, right?
Yes.
But
Yes.
but when we say the discrete, when we say the medium, okay, so actually in the meaning that the observation itself, not observation, the value itself need to be discrete. Then
Okay.
you have a medium, but in that case, it doesn't apply in this case. But
Oh yes.
if it's a statistic by loads, then there is a medium.
Okay.
Then
Okay.
there's a medium. So this a medium. How to get is actually you go to the process, the list of the, where is it? Actually go to the process list. Okay, you go
Yeah.
into this one, then you get maybe the cycle time. You query all the cycle time, then will become the list of the time. Then you can get a median to say that what are the median of the cycle time. Now this is defined. This is applicable.
Okay.
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 Yeah.
Okay. Okay. Okay.
So this concept is different. Okay. Yeah. How about the third question?
I forgot, sir. I'll recall and come back again.
Sorry again.
Sir, I forgot, sir. Just I'll if I
It's okay. It's
remember.
okay. Yeah. Later you can. Yeah. Maybe you can write down the paper as well.
Right,
Yeah.
right,
It's
right.
fine. Okay. So any other questions up to now? Up to the warming up? Okay. So if no other questions, I will continue to introduce the other uh, methods, the functions of the hour counter. Actually, a lot of the other like very interesting functions we have. For example, okay, I'm not quite sure whether I can go through all of them, but today and even some of the function, if you are interested, later we can summarize a certain document and go through it. Okay, so one thing is, if we want to look at how many have joined the queue, okay, how many customer have joined the queue, okay, so in this case, what does this mean? Meaning that we only look at the entrance of the queue to see that how many has entered. I do not really care about how many has left. Okay, as long as I join the queue, I will actually record it. Okay, so in that case, how do we do it? Simply, we still use this hour counter in queue, but instead of query on the average count, okay, so what we do is I just show that some other info, for example. Then I just like show to you how easy we can use this one. So just a dot uses our counter to say dot in total increment. Okay, so in that case we can simply here let's like remove the warm up part. Okay, so here we can actually look into the other info. Is actually 17, meaning that the total there will be a 17 enter the system, and also you see that if you look at how many process, also the 17. Okay, so this is actually the value of the total increment. So basically, this one is looking into this this chart, but see that how many times we actually have an increment. Okay, so this time we need to bear in mind that there will be some things you need to know. As for example, this is a little bit spike here. Okay, so you see that this spike actually does not contribute to the average count. So even you with or without this spike, then you can see that the average count will not make a difference, right? Because this one, the rectangle under it, because the time length is 0. So no matter how large you goes when this event happen, but actually at the same time it's decreased back to the original level. So in that case, average count does not matter at all, doesn't change at all. Okay, but if you look into the total increments, this aspect will make a difference. When you have these things, meaning that the total increment will be considered to be added by 1. Okay, then of course the other side, the decrement will also be added by 1. So in that case, actually it's a make a difference. So yeah, this is something you need to bear in mind. So sometimes we use we use a way to, I mean, in some of the implementation of the QE model, so actually for this one we can ignore this spike. So that's why later when you see a total increment or total decrement will be a little bit different. Okay, and yeah, I think symmetrically we also have a dot total decrements. Yeah, it's actually a total count of decrement. And also we have another interesting things is actually we have increment rate. Okay, increment rate is actually the total number of increment divided by hours, by the time length. Okay, so this will be the increment rate. Asymmetrically, we also have a decrement rate. Okay, so let's see what is the decrement rate here. So basically, I think will be 17 also. Yeah, because now we only run for 1 hour. So 17 divided by 1 hour is still 17. Okay. So yeah, so this is actually about the increment and the decrement rate. Sometimes actually this is very important when we use the hour counter, for example, in our like a pod project. So sometimes we are looking into the problem of how many boxes, containers have been processed by the key crane or yacht crane per hour. So in that case, actually, we are using this decrement rate and increment rate or decrement rate, okay, to query for these properties. So basically, whenever we start as a new container, we observe we observe change by 1. Whenever they process the one container, we observe the change by -1. Okay, so at the end is when simulation is ended, we just query for the increment rate. Okay, then we can see that how many have been processed. But if you want to look into utilization of a key crane or yacht crane, so we need to look into the average count. Okay. And also another like a very interesting function is to see that sometimes when we query for the rate, okay, we have this concept of the gross rate. Okay, gross key crane rate or gross yacht crane rate. So what does this really mean? It actually means that I do not consider the overall processing rate of the equipment, but we only consider the rate when this equipment is allocated to certain job. Okay, because if the equipment is not allocated to a job, so it's not fair, okay, to see that how fast you work. For example, I mean, some of you as a staff of the center, if I do not assign you any task, then the second day I ask, how much you have to complete your job? You say I have to complete nothing because you haven't assigned me anything. Then I will rank you as the lowest, okay, for your work efficiency. So this is unfair, right? So only when I assign some job to you, then I start to look into your work efficiency. So I think this will be fair. So in that case, is that we also need a kind of mechanism to see that turn on and off of the hour counter for sometimes. For example, now we have these things. I want to like on and maybe like a turn off, for example, here, if you look into this one. For example, if I want to like warm up for 1 hour, okay, for example, I want to warm up for 1 hour, then keep it running for another hour, then we'll turn off this certain of the hour counter for 1 hour because it doesn't have any like work for it, okay, then it will actually on, okay, for another hours, okay, so after this 1 hour break. So in that case, how do we do it? So basically you can do it in this way. So we let the simulation to, yeah, maybe that's just adding the warm up back here. Okay, let's just like warm up this one for 1 hour. Okay, then I will run it for 1 hour. Then after 1 hour, I will do one things. I will let 1 hour counter, for example, the in queue to be off. Okay, for some I do not really care what the queue is performing for that hour. So what we can do is I just make a pause to this hour counter. Okay, then I run the simulation for another 1 hour. Then after that, I want to like bring back this statistics. Okay, so I want this to be resumed. Okay, then after that, I will run another hour. Then I will query for the statistics. Okay, so in that case, so actually, I mean, I think it's better to later I will do a graph for this one. So you see that your warm up for 1 hour probably is here. Then all the histories before will be removed. Then start to count until here, run for 1 hour. So this 1 hour, all the statistics is considered. Okay, then it will be paused. The pause is only hour counter is a pause. Okay, so the system is still going on. It just whenever observation recorded, the hour counter is just ignore. I mean, ignore by ignoring the cumulative information, okay? But snapshot information are still there. Until they finish here, then you start to bring back the hour counter again. So all the things accumulated in the last hour will still be counted, okay? So in that case, this actually showing the result, okay? So you see that this like average count will be all different. Yeah, of course, I mean, the timeline is different. So, but later you can see that if you want to continue for like 3 hours, the result is actually very different from here. Okay, for this average queue length. Okay, if I'm not wrong. Okay, so this is actually for the pause and resume. Okay. So for this part, are you okay with it?
Sir, I have one question.
Yes.
Sir, like if suppose if we are just now you told that we run for 1 hour, then we pause the queue. Okay, so will the snapshot of the previous 1 hour which was in the queue will come back to us, or it will go and we will the queue will be uh,
Yeah, the snapshot information will still be updated even when
will
the hour counter is paused. So the snapshot will still be going on. Okay.
so it will be with us.
Yeah, it will be with us. It will still be there. Snapshot will be there. It's just this a change of snapshot does not incur any change in the cumulative value.
Okay,
Yeah,
so
so basically, I think use this graph will be easy explanation. So basically, I think it's actually doing these things. It's actually black out, okay, one part of it, okay? Mean that what is happening inside, we just ignore. For example, the warm up actually is doing these things. Warm up is actually blacking out. Okay, warm up, what the warm up is doing is that warm up is actually, for example, at this time point, you are doing the warm up. So what you do is you from this time point and all the histories before will be removed. So this is a so-called a warm up. Pause and resume in the way that this is a pause. Then when you resume until the time of resume, which actually the right boundary of this blue box, then only this part is removed. So in that case, whatever statistics, okay, you see from here, okay, as a sequence of the warm up and pause and resume will be resulted only in the area which are showing up here. Okay, on this area, this 1 hour and another hour after. Okay, so for example, the average count, we're only looking into the gray areas here, divided by this length plus this length. Yeah, so this will be the average count. What will be the total increment and increment rate? Total increment will be the increment only happens here. Although the snapshot information is updated, but it does not count into the total increment. Okay, then total decrement is the same thing. Increment rate and decrement rate are also the same thing. Okay, so and also later we'll talk about the histogram. So actually the same. It's only consider this part which are showing here. Okay. Yeah, Monica.
Okay, sir.
Yeah.
Yes, yes. Okay, sir. Sir, one more thing.
Yes.
Can we run the simulation in interval? Like, I want to run from 4 hours to 8 hours.
So sorry again. Sorry again.
Can we run the simulation in interval? Like, I want to run from fourth hour to the 8th hour. Can I do like this?
Yes. So what you can do is you warm up for 4 hours. You warm up for 4 hours, then you run for another 4 hours. Okay.
Okay.
You cannot. I mean, we do not have this function to run from starting time and end time. Yeah, probably we can consider that, but it's not like a quite useful. I mean, it's not like a strong requirement for doing in that way. So I think a way we can play with it is just here we see that warm up for 4 hours, then you run for another 4 hours. So exactly, I think this is exactly what you want, right?
Actually, no, sir. What I was considering is like many people when I hear Ratna ji and Kundu speaking, like they run the simulation and then they run for, they say that we have run for this hour, 10 hours, then other one will say I've run for 60 hours, like that they run. So like if 10 hours one has run, then we can pick the result of 10 hours and need not waste the time for the first 10 hours and start for from the 10th to the 60th hour, like that.
No, the thing is, how can you start from 10th hour?
No, we
If you,
cannot. Yeah,
yeah,
okay, okay.
it's like you construct a building. So I just want the third story, 3 to 10, without building 1 to 2 or the foundation. How can we do so?
No, sir, but if suppose somebody has built, if like if I have already started building the story and one day I have built it up till second story, and then
So in this case, what we need to do is we need to get the status, the state
yeah,
of the state variables at the end of the day 10. Okay.
okay, okay,
Then we initialize all the dynamic properties here. I mean, instead of to see 0, empty, so we need to get a whole set of this information. As you said that someone had already built this. So
yeah,
we need to get what is this one at the end of the last build. Okay. Then
okay,
probably this last build we need to put into the statics, model statics, okay, the
okay, okay,
configuration. So here is
okay,
that using a constructor, we actually give the initial value to all the dynamic properties. Okay.
okay,
Then we continue straightforward. We continue for 4 days. Then this
okay,
will become what you want. Okay.
okay,
Okay.
okay,
So
okay, okay,
actually, this is another way we're doing the warm up. Is we do not run the simulation model, but actually we start the model with a warm status. Yeah. So this is some things I mean, it's also some of the common practice. But the thing is, usually to get such kind of the running time status will be difficult and sometimes actually require running of the simulation. So eventually it become the same.
okay,
Yeah,
okay, okay, sir.
yeah, yeah.
Okay,
Okay. So yeah, so I just want to like show you a little bit more about what our counter can do. So if you like put a dot here, let me see what are the other things we can pause the actually meaning that you are checking whether the currently this our counter is a paused or not. Okay, so this actually what pause is a boolean variables. So Yeah, the working time ratio is something when you have this a pause and a resume. So actually this one is to return to see that yeah, okay, it's not accepted. Okay. Working time ratio. Okay, so this actually to see that the pausing time, so what is the percentage, what is the ratio of this to the total time observed. So basically if you look into this one, working ratio is actually looking from the length from here to here, okay, this portion plus this portion divided by the portion starting from here to here. Okay, because of warm up, whenever it's a warm up, so all the previous history we do not care. Okay, so the total time will become here to here. But because this portion is paused, so it will remove. So working ratio become this one plus this one divided by this whole length. Okay, so this is actually the working ratio. Let me see what are the other things we have here. Okay, histogram. Yeah, okay, histogram. Yeah, I think maybe I won't touch a histogram now. It's a little bit complicated. Also, I think we need some of the testing and also want to yeah, probably I think some of you later can help me to do this test, okay, to see that whether how this histogram can whether it works, okay, for some of the testing cases. Okay, let me see that what are the okay, last count and last time. I think this will be last count. I think the last count will be yeah, both of these will be very important. Last time basically is just the last time stamp. So basically it's the same as the simulation, the model dot clock time. So this one actually is the same as should be the same as the model dot clock time. And just to tell you that what is the last like last time the hour counter actually observed. So this one does not really matter. Then this last count is actually the snapshot information I just mentioned to you. Okay, so what is the last value we observed? Okay, it's absolute count. It's not change, but absolute count. Then the other things, cumulative value. So cumulative value is different from the average count. Is average count equals to a cumulative value divided by the total time. Okay, so if you really want to look into how large is the area, you use a cumulative value. But this is very well the very rare. Using this one is very rare. Average duration. Okay, the average duration is something so interesting. Is um, you can see here from this chart is what is our counter is recorded. Okay, so that's why from this chart we can see that sometimes someone comes in, someone goes, sometimes someone goes out, decrease. It does not really show how long one load will spend inside. Okay, but actually very interestingly is that if you know the Little's law, okay, if you know Little's law, so average cycle time in the system is actually equals to the okay, so average number in the system, okay, so average count in the system is actually equals to the arrival rate times the durations, the average durations. So this is actually the Little's law. By using the Little's law, the hour counter is able to get a average arrival rates. So basically it's actually increment rates, okay? And also it's able to observe the average count of the system. So if it's able to get these two information, provided that this system is a stationary in the sense that how many comes in is roughly equal to how many goes out, okay? So if this assumption is valid, then we can just use the average duration to find out how long the loads were spent inside. So here you see that, okay, here you see that yesterday actually we found that this average cycle time is some things we use the statistic by loads to come out, okay, to generate. So now I want to use this average cycle time, okay, again, but this actually by Little's law, okay, to show you that how we can use the hour counter to come up with this cycle time and to see that whether they are the same. So I'll see the average duration. Okay, and total minutes. Let me see how close this two value is. Let me just warm up for 1 hour and run for another 1 hour. Okay. I don't know. I never tested this before. Probably I will fail. Then there's a bug to fix. Okay, see whether it was successful. Average cycle time is 1.73 minutes, but little slow. Okay, so if you use the estimation by using a little slow, we observe the cycle time will be 1.79. So yeah, it's quite close. It's quite close. So it means it's actually successful. Okay, so meaning that by using the hour counter, we can also get an average cycle time without really looking to the statistic by loads. This will be more efficient in the sense that we don't need to like maintain, especially when the amount of data is very huge. A huge number of the loads have been processed. So by doing this, we will calculate some time and will consume some time, but this one will be very fast. Okay, so this is one thing. Another things I want to mention to you, maybe another few minutes, okay, is that this hour counter is actually very, very efficient if we do not keep the history, observation history, in the sense that every time point, every time we count, okay, we observe, every time we observe, actually the previous history was not recorded. What is recorded is actually the cumulative value. What is the total average? This is a calculated, this is recorded. But where is this rectangle? Where is this green rectangle? Is something is not recorded, it's not traced. So this is to ensure that the hour counter is very efficient in terms of the memory and also the computational time, okay? But what are the missing part is that if we want to look into to see that, okay, in the history, how much time the count is actually 1, how much time is 0? For example, you see that 0, you see how much time is 0, how much time is 1. This kind of information we cannot answer. We cannot answer by without like tracing the history, okay? So this is actually one things we need to bear in mind. So that if you really want to have like those information, then we need to turn on one things actually the keep history property. So that's why in the model, when we have here the hour counter, we need to this as a keep history as true. By default, it's false. Okay, we need to keep this as a true, so that we can actually apply something like a histogram, and also like a percentile. Let me see whether percentile is there. Whether percentile, yeah, percentile is also there. So if I'm not wrong, the percentile, for example, the 80% percentile. I mean, if you keep a history, then those things will be available. Okay, I think this is something that maybe later you can help me to take a look, and maybe you can do some testing to see that whether this will be possible. I think in the bigger group training, especially the first batch, I want to mention about this part in the bigger group. Okay, because this is something that I think we still need to test for a while. Percentile and histogram. Okay, histogram. Okay, when we come up with a histogram, then we need to set what is the interval. Okay, something like this. Okay, so what does this histogram and percentile actually mean? Let me explain the percentile first. Percentile is basically to see that now we can see that sometimes the system state the value is 0, sometimes it's 1, sometimes it's 2. So we can see that maybe, for example, 50% of time is 0, 40% of time is 1, then the 10% of time is 2, for example. Then in that case, if you look at 90% or 91 percentile, it will be 3. No, it will be 2. But if you look at the 90 percentile all the way to 50 percentile, we'll see that the value will be 1. Then if you want to look into the 0 percentile all the way until the 49 percentile, then the value will be 0. Okay, so this is a percentile, this is a percent, is actually referring to the time, refer to a time. Then histogram will also be the same. Histogram will to see that, okay, now you have a 0, 1, and a 2. So basically you have like a 3 interval. One is from the 0 to 1, the other from 1 to 2. Sorry, one is from 0, the other is actually sorry, 0 to 0.5, for example. Okay, basically is that the first one is actually we histogram, we have like a 3 interval. The first one is a 0 because now we have an integer. The second one will become a 1. The third one will become a 2. So actually this histogram is able to show that how much percent of the time is 0, how much percent of the time is actually the 1, how much percent time is 2. So this kind of output will only be applicable if we turn on the keep history. Okay, turn on the keep history of our counter. But this sometimes this is actually a very useful statistic to use. Yeah, but maybe I will need you to help me to do some of the testing. Okay, so any questions by now? Maybe you can just ignore the last part when this history of our counter is discussed. But for the other part, whether you have any issue. Okay, so if no, I think it's the time to end today's session. I think maybe tomorrow let's pause maybe for one day because tomorrow I will have this training for the whole group. So let's pause this one. We will resume this small group from the next Monday. Okay, so I think maybe the next Monday I will try to clear some of the questions. Some of the questions I listed last time in the tutorial one. Maybe I will also come up with some other questions and trying to discuss with you.